So we classified matter by its physical state. We can classify it differently by its composition. Just like you can classify Legos in different ways, right? I have 6 kids. We have a lot of Legos. I mean, you would not believe how many Legos. We've been collecting Legos for 20 plus years. We have a lot of Legos. You can classify Legos by their colors, right? You could also classify them by their shapes. Or you could group them by, well, this went to this particular set and this one went to this particular set. And so we can also classify matter in different ways. So looking at the composition, we have 2 categories. We have a pure substance or a mixture. In a pure substance, there's only one kind of atom or molecule that's present. Here's another illustration of water. Water is a pure substance. All of these particles are the same. There's only one kind of particle. In this case, it's a molecule. Other pure substances might have particles that are atoms, but all the atoms are the same. In a mixture, we have 2 or more different types of atoms or molecules combined. So the types of particles, there's more than one kind of particle. And the proportions are variable. Then we can look at that pure substance and identify which ones are elements. An element is a pure substance that cannot be broken down into simpler substances. So let's go back and look at the water. Each of these water molecules contains 1 red ball and 2 white balls, 2 hydrogen atoms, 1 oxygen atom. Molecules can be taken apart. If I take that apart, now I've got oxygen and hydrogen. Water is not an element. When you have an element and you take it down into its individual pieces, all the atoms are the same, and you can't break it down into anything simpler. This is a compound. We can break it down into something simpler. So there's no chemical transformation that can decompose an element into anything simpler. The known elements are listed in the periodic table, and we now have a nice periodic table on the wall. Those are all of the known elements. A compound is also a pure substance. Water is a compound. It's composed of 2 or more different elements in fixed proportions. The difference between a compound and a mixture, we've got fixed proportions. For water, we always have 2 hydrogen atoms to 1 oxygen atom. You can also have a mixture of hydrogen and oxygen gases. If you have such a mixture, you should be careful because it's very flammable. But you could have a little bit of oxygen and a lot of hydrogen, or you could have equal amounts. It could be variable. In water, which is a compound, it's a fixed relationship. Compounds are more common than pure elements. Compounds can be decomposed into simpler substances. We can take water and break it apart into hydrogen and oxygen gases. You can actually do that by taking a 9-volt battery and dropping it into a glass of water. That's something you can try at home. Some of the things I'm going to talk about you should not try at home. That one, feel free to try at home. You drop it in, what you'll see is bubbles forming at each of the terminals. One terminal's making oxygen gas, one terminal's making hydrogen gas. A mixture has different substances, but they're not chemically united. So they can be separated and the proportions can vary. So it's important to understand the difference between an element, a compound, and a mixture. Any questions about those? Let's look at this illustration of air and seawater. So here's a simplified illustration of air. Nitrogen molecules and oxygen molecules. There are 2 different kinds of particles in this. That's the tip-off. This is a mixture. Down here, this is also a mixture. We've got water molecules and we've got salt. And so it's a mixture. You could have more or less salt. These are mixtures. We can classify mixtures by how they mix. We use a lot of prefixes and suffixes in science. Homo is a prefix that means the same. Hetero is a prefix that means different. A homogeneous mixture has the same composition throughout. If you mix sugar and water, stir it up, it'll be the same throughout. The top will be just as sweet as the bottom. If you put sand in water and mix it up, what happens? The sand goes to the bottom every single time. That's a heterogeneous mixture. It does not mix uniformly. The sand clumps up at the bottom. We'll pick up with this next Tuesday.